Huawei keyboards, right? We use them every day, but how many of us actually know how they work? It's like magic, you press a key and boom, the letter appears on the screen. But behind this seemingly simple act lies a fascinating world of technology. Every time you hit a key on your keyboard, you're setting off a chain reaction. This reaction translates physical motion into electrical signals that your computer can understand. Think of it like a secret code. Each key has its own unique code that gets sent to the computer, telling it what to do. It's pretty amazing when you think about it. But not all keyboards are created equal. There are two main types, mechanical and membrane. Mechanical keyboards have individual switches for each key, giving you that satisfying clicky feel. Membrane keyboards, on the other hand, use a pressure pad system. They both do the same thing, but they go about it in different ways, and each has its own pros and cons. Mechanical keyboards are known for their durability and tactile feedback. Membrane keyboards, however, are usually quieter and more affordable. So let's break it down, shall we? We'll explore the inner workings of both types and see what makes them tick. Whether you're a gamer, a writer, or just someone who types a lot, understanding your keyboard can make a big difference in your daily life. So next time you sit down to type, take a moment to appreciate the magic beneath your fingertips. It's not just a tool, it's a marvel of modern engineering. So let's dive in and uncover the secrets of how keyboards turn our keystrokes into digital commands. Ready to explore? Let's get started. We'll break down the differences, the pros and cons, and help you decide which one is right for you. So, let's break it down, shall we? First up, we've got the mechanical keyboards. These are the heavyweights in the keyboard world, known for their durability and performance. These bad boys are all about that tactile feedback. Each key press feels distinct and satisfying, making typing a more engaging experience. Each key has its own individual switch, so you get a satisfying click or clack with every press. This is why many people find them more enjoyable to use. Gamers and hardcore typists swear by them because they offer better precision and responsiveness. The tactile feedback can improve typing speed and accuracy. Plus, they're built to last, like that friend who always seems to outlive their phone. Mechanical keyboards can withstand millions of keystrokes, making them a long-term investment. Then, there are membrane keyboards, the more common and affordable option. These are the keyboards you'll find in most offices and homes. Instead of individual switches, they use a single membrane sheet with pressure pads underneath each key. This design makes them cheaper to produce. When you press a key, the membrane flexes and completes a circuit, registering the keystroke. This mechanism is quieter but less tactile. They might not be as fancy as mechanical keyboards, but they get the job done. For everyday tasks, they are more than sufficient. Now let's talk about how these keyboards actually work. Understanding the inner workings can help you appreciate the technology behind each keystroke. It all starts with a little something called the key matrix. This is the backbone of your keyboard, responsible for detecting which keys are pressed. Imagine a grid of wires running underneath your keyboard, like a secret underground network. Each wire intersection is a potential key press waiting to happen. Each intersection of these wires represents a key. When you press a key, it completes a circuit at that intersection, sending a signal to your computer. Mechanical keyboards have gained a cult following, and for good reason. These keyboards are known for their durability, responsiveness, and that oh-so-satisfying tactile feedback. The secret lies in their individual mechanical switches, which provide a distinct click or clack with every key press. These switches are what set mechanical keyboards apart from the competition. They offer a level of precision and control that's hard to beat, making them a favorite among gamers and professional typists. Plus, the tactile feedback provides a sense of satisfaction that's hard to describe. It's like the keyboard is talking back to you, letting you know that your keystrokes are registered. But it's not just about the feel. Mechanical keyboards are also built to last. They can withstand millions of keystrokes without breaking a sweat, making them a worthwhile investment for serious users. On the other side of the keyboard spectrum, we have membrane keyboards. These keyboards are everywhere, from laptops to office desktops, and for good reason. They're quiet, affordable, and get the job done. While they might not offer the same tactile feedback as their mechanical counterparts, they have their own set of advantages. Membrane keyboards are known for their slim profile and quiet operation. They're perfect for those who prefer a more discreet typing experience or work in noise-sensitive environments. And because they're more affordable to manufacture, they're often the go-to choice for budget-conscious consumers. While they might not be as durable as mechanical keyboards, membrane keyboards are still a solid choice for everyday use. They're also more resistant to spills, thanks to the protective membrane layer that shields the internal components. Section 5. The Key Matrix, a grid of secrets. Now let's get down to the nitty-gritty of how keystrokes are actually registered. Underneath all those keys lies a secret grid of circuits called the key matrix. It's like a game of Battleship, but instead of ships, we have electrical signals. When you press a key, it pushes down on a switch, which completes a circuit in the key matrix. This action sends a signal to the keyboard's brain, a tiny chip called the microprocessor. Now, this microprocessor is a busy bee. It has to figure out which key you pressed, filter out any accidental double presses, and then send the correct code to your computer. Think of it like a game of telephone, but instead of whispers, we have electrical impulses traveling at lightning speed. It's pretty impressive when you consider how many keystrokes we make in a day, and how quickly the keyboard manages to keep up. Section 6. From key press to signal. The microprocessor's role. The microprocessor is the unsung hero of the keyboard world, often overlooked but absolutely essential. It's the brains of the operation, responsible for taking those raw key press signals and turning them into something your computer can understand. Without it, your keystrokes would be meaningless. It's like the translator between your fingers and the digital world, converting physical actions into digital data. When you press a key, the microprocessor springs into action, instantly recognizing the input. It identifies the row and column of the activated key in the key matrix, determining its unique location. This is a crucial step in the process. This information is then used to generate a special code, known as a scan code, which is unique to each key. Each key on your keyboard has its own unique scan code, like a digital fingerprint, ensuring precise communication. But the microprocessor's job isn't done yet. It has more tasks to handle. It also has to deal with a pesky phenomenon called key bounce, which can cause multiple signals. When you press a key, it doesn't just make clean contact once. Instead, it bounces, creating multiple signals in quick succession. The microprocessor filters out these extra signals, ensuring that only one keystroke is registered for each press. This filtering is vital for accurate typing. Without this filtering, typing would be chaotic and error-prone. The microprocessor ensures smooth and reliable communication between you and your computer. Section 7. Decoding the digital language, scan codes and characters. Once the microprocessor has done its magic, it sends the scan code to your computer. But the computer doesn't speak scan code, it speaks character code. That's where the keyboard driver comes in. It's a piece of software that acts as an interpreter between your keyboard and your computer. The keyboard driver receives the scan code and looks it up in its internal dictionary. This dictionary maps each scan code to its corresponding character or command. For example, the scan code for the A key gets translated into the character A on your screen. But it's not just about letters and numbers. Scan codes can also represent special keys like Shift, Ctrl, and Alt, as well as function keys and multimedia controls. The keyboard driver handles all of these translations, ensuring that your computer understands every keystroke you make. Section 8. A symphony of signals, keyboard to computer. The communication between your keyboard and computer is a beautiful symphony of signals. It all happens in the blink of an eye, but there's a lot going on behind the scenes. Once the keyboard driver has translated the scan code into a character code, it sends this information to the operating system. The operating system then passes the character code to the currently active application, like a word processor or a web browser. The application then decides what to do with the character, depending on the context. If you're typing in a document, the character will appear on the screen. If you're playing a game, it might trigger a specific action. It's a complex process, but it all happens seamlessly thanks to the magic of technology. Every keystroke you make sets off a chain reaction of electrical signals and software interpretations, culminating in the desired action on your computer. Section 9. Choosing your weapon. Finding the perfect keyboard. So, there you have it, the ins and outs of how keyboards work. From the satisfying click of a mechanical switch to the quiet efficiency of a membrane keyboard, each type has its own unique charm and purpose. When choosing a keyboard, it all comes down to personal preference and intended use. Gamers and serious typists might gravitate towards the tactile feedback and durability of mechanical keyboards, while those seeking a quieter and more affordable option might prefer membrane keyboards. But no matter which type you choose, you can appreciate the intricate technology that allows us to communicate with our computers through the simple act of typing. So the next time you sit down at your computer, take a moment to appreciate the marvel of engineering that lies beneath your fingertips. It's a testament to human ingenuity and a reminder that even the most commonplace objects can hold hidden wonders.